Not having to pay a single penny for energy in your building? Sounds like utopia? No, it can be the reality. Primarily, it's about the amount of investment and whether it pays off. It seems that a great amount of people still does not have the correct information of how these technologies are pretty easily implementable, and I will say it's no rocket science. Houses like this have been built for decades throughout the world, and so it's just about the right design and combination of technologies to make them self-sufficient in energy. I'll be covering the basic systems to provide the building with self-sufficiency in terms of electrical energy, in terms of water, in terms of water treatment, as well as some other technologies that might be added on top of that. And I will also cover some legislative approaches and how legislative actually views and perceives autonomous buildings and some specific terminology. As you could probably tell, I'm a huge advocate for autonomous houses and systems that lead to that, because we have all seen what the energy market did, especially in the past few years, and how unpredictable it can be. Therefore, what I say is that independence and self-sufficiency is the key not only to survival, but to actually be able to thrive. Legislative real fast. Who likes legislative is the question. However, I believe this will help us to actually get on the same level in terms of the terms that we use. So I managed to find this presentation, which is from 2020. However, I believe the information should still be correct. Let's dive right into that. So concepts of NZEB buildings. We're gonna discern small n and capital N later. And we're also gonna discern these types of terms. So what is most interesting for us is the autonomous zero energy building, which is not grid tied. But we also have net zero energy cost building, net zero site energy building, net zero energy building, net zero energy emission buildings, zero source energy buildings, and last but not least, passive buildings. So let's have a look. Overall, this is basically a definition by the United States Department of Energy, which says a zero energy building produces enough renewable energy to meet its own annual energy consumption requirements. Sounds pretty straightforward, right? So let's get into more complicated things. We have 4 types of NZEBs, and look at that. It's like capital N now, comes very soon. And so NZEB A, footprint renewables net zero energy building, means that actually the sources are available within the buildings, that actually like the sources are integrated within the building. So it means that there's a PV on the roof and other potentially other systems that are integrated in the building. B means these systems can be on site, don't necessarily have to be connected to the building, but can be in lots or adjacent open space, such as a parking lot or maybe a structure in the garden, something like that. C means that it is still net zero energy, however, the energy is imported, and so the difference between that is this case actually incorporates having, for example, a pellet heating system, which means that the pellets have to actually be imported from offsite. And D, last but not least, it combines A, B, and C, but also says that the imported energy has to be certified, which is basically another legislative. So we're not gonna dive into that anymore. This is the most interesting thing, because the autonomous zero energy building is not grid tied, which means it operates completely independently from any external energy infrastructure or source, and therefore it has to produce
its own energy. Passive buildings are very interesting as well. The thing to say here is that passive buildings are usually not incorporated in legislative in countries, because passive building standard is a kind of an independent standard defined by the German Passive House Institute in Darmstadt, and the rule of the thumb is that it uses up to 15 kilowatt hours per square meter per year for heating and cooling. It can be defined by the 0.6 air changes or 50 pascals pressure. Basically, Passive House Institute uses their own software. Well, software is maybe a too strong word for that. It is basically a macro Excel for calculating the energy consumption of the building, and this Excel then determines whether it falls under the passive building standard. As I said, it's usually not incorporated in legislative, so it's kind of an independent point of view, which is really nice because it can therefore be used worldwide. So a net zero energy building receives all necessary power through renewable resources and is not dependent on fossil fuels or existing infrastructure. Well, this is very general to say, so let's move on to net zero source energy building, which implicitly says that the energy should be generated on site. And so this one, as opposed to the net zero site energy building, also includes producing enough energy to cover the transmission losses. And so that in reality they need to generate a little bit more energy, because it's the point of view of which you're looking at it from. Net zero energy cost building is the perspective of cost, and this is not really the best way to look at it, because the cost is variable throughout time, and so I wouldn't really use this. Net zero energy emission building means just focus on the emissions there. And now finally we're getting to discerning what small NZEB and capital NZEB means. The difference is that capital NZEB means that the primary energy use throughout the year is zero. Does it mean it's autonomous? No, it can still be grid tied. That's important to discern. However, it's different from small NZEB, which is a nearly zero energy building, and it literally means that the primary energy use can be more than zero. We're gonna dive into that. Small NZEB is pretty much the current standard for buildings. So all buildings built, as we agreed on within the European Union, at least should be in the small NZEB, nearly zero energy building standard. Now, there is a timeline. This is, What is interesting here is not this, not this, not this, but here. So, again, I believe they meant small NZEB, so otherwise it doesn't really make sense. But what it means for example, single family houses is the annual energy consumption per square meter, which should be from anywhere 15 kilowatt hours square meter a year to 30, which, as you can see, is more than the passive building standard. So it's more energy demanding, than therefore less efficient. So we could say the legislative is kind of loose, and if you decide to design a building in the passive standard, it's still going to be more efficient than what the legislative as of now demands, right? The standard is of course different for offices, and is again different for different climate zones. So I was focusing only on zone 4, which is mostly like Central Europe and stuff, but if you were to go to a different zone, it differs there. Good. Yeah, this is how it's calculated, and what is interesting here is basically that different countries use different ways of determining and of meeting the NZ definition. Some countries use the Minu value of building envelope. Most countries use the primary energy approach, which kind of makes sense, but there it is. legislative differ. And we also can see different climate zones, different energy consumption, according to the same NZEB standard. So what it actually wants to illustrate is that the same standard doesn't have the same specific energy consumption everywhere because, well, it's adjusted by the climate zone. Good. What was the last thing here? Yeah, these are some like simple schemas. Thank you for your attention. That was it. So pretty much we defined small NZEB, capital NZEB, autonomous buildings, and some other terminology to describe buildings. And what we are trying to achieve in the best state of things is the fully autonomous building. Thank you.
I myself had the chance to work with these systems. I will mention especially the rainwater collection system. There was one instance of that system that I worked on from the design phase to actually building it. And so I can provide experience on not only the theoretical side and design of those systems, but actually of what it means for the user to take care of systems like that, for them to be maintained well and work as long as they need to. What aspect of autonomous housing excites you the most? Share your thoughts in the comments and let's discuss how we can make these technologies more accessible for everyone. Don't forget to comment and subscribe. See you next time with other deep dives into sustainable technologies. Take care.